Buenos dias, all you virtual learners out there. Mr. Cornell ready to go over some tangent function stuff with you. So in all these previous lessons we've done so far, we've really concentrated on the sine and the cosine function only, and we've left the tangent kind of just sitting out in the rain. So we're going to let him back in the house for a little while, and we're going to kind of figure out what his whole deal is and where he fits in on all this stuff. So if we remember back from before, in earlier units, we looked at that the tangent from back in the day in geometry, that is the opposite over adjacent side. And that's kind of labeled here using this angle theta there. So that was kind of the old stuff and what we were learning about in geometry in the tangent function. And so just to recap that quick, let's say if I wanted to find those three functions, that sine, cosine, and tangent function, using these triangles given here. So if you look at this first one, okay, if we run a label, this is the opposite side. The opposite of a 90 is your hypotenuse side, and then you have your adjacent side there. So since we are missing this side here, and we have right triangle, you can always use the Pythagorean Theorem of a squared plus b squared equals c squared. And it's going to come important later, so kind of make sure you have that down. So it's 4 squared plus x squared equals 5 squared, 16 plus x squared equals 25, x squared equals 9, so x is equal to 3. So the value here of that opposite side was 3. So now if I was going to go ahead and evaluate the three trig functions, the sine, the cosine, and the tangent function, the opposite over hypotenuse would be 3 over 5. The cosine, which is the adjacent over hypotenuse, would be 4 over 5. And then the tangent function would be opposite over adjacent, which would be 3 over 4. Okay, so there you go. There's your first one there. Then we went and did the same thing for this guy. This is your opposite. This is your hypotenuse. This is your adjacent. Okay, same game. So we do 1 squared plus x squared equals 2 squared. 1 plus x squared equals 4. X squared equals 3. So x is equal to the square root of 3. If I go ahead now and I evaluate my three functions, the opposite over hypotenuse would be radical 3 over 2. The cosine would be 1 over 2. And the, here I am, the tangent would be opposite over adjacent, so radical 3 over 1. Or you can always just leave that as radical 3. So that was kind of your basic, that's your geometry stuff, that's your old stuff. So then what we started to do is we introduced the unit circle, right? And we can have missing sides of a right triangle and still use the Pythagorean theorem to find the ratios, okay? Many of which have radicals, so if you remember this unit circle, a lot of them did have radicals, radical 3 or a radical 2 in there. And so they would be irrational numbers, numbers that are decimals that have no ending and cannot become a fraction. So just as we did with the sine and the cosine, we can also define tangent in this unit circle. So consider the unit circle shown below. So here it is. If x and y represent a point on the circle, how can we define the tangent function of this point? So that's just like old school stuff. So if this is the tangent, which is opposite over adjacent, so this, okay, if I just kind of wrote it right there, the opposite is y, the adjacent is x, so it was y over x. Nothing new there, super old. But then what we started to do is we started to give x and y different names. We stopped calling this x and we started calling the x to be cosine. We stopped calling him y and we started calling him sine. So x went along with cosine, y went along with sine. Well, if I go ahead and I said, well, what is the tangent function equal to in terms of sine and cosine? Well, substitute it. I would say that it would be the sine divided by the cosine. Okay? So kind of, again, it's something that we covered before, or if you didn't know, surprise, here it is. And now let's kind of tie this all together and say, well, who cares? So Sine tangent theta now for you is sine theta over cosine theta. So using the unit circle and the definition of tangent in terms of sine and cosine, find the value for each of the following. Okay, don't leave complex fractions, which means don't leave a fraction over a fraction. So basically, remember that the unit circle at certain degree measures had points. Okay, a radical 2 over 2, radical 2 over 2, and then those were x and y. So what I'm asking you is find 60 degrees, what point is that, and then write its fraction, and then simplify it. Right, good. So obviously we all have the unit circle memorized, so this shouldn't be too difficult. Yeah, right. So, just so happens I have a unit circle right here. So that first one asked for the tangent of 60. So here's your 60 degrees. So here is your x point. Here is your y point. So tangent is y over x, right? So it would be radical 3 over 2 over 1/2 is equal to tangent theta. So just so you know, you're writing that right here to find the tangent of 60. Now we can't leave that, right? So we're going to have to get rid of that. So remember, to get rid of that, you do this. So this becomes right there, radical 3 over 2. These 2's cancel. You're left with a radical 3 over 1. Final answer, radical 3. So the tangent of 60 degrees, the answer is radical 3. All right, that's all you have to do. Try B, C, and D if you want. I'll throw the unit circle there so you can kind of follow along with that. All right, so the next one said tangent of 45. So you're using this x and this y point. So that would be radical 2 over 2 over radical 2 over 2. So that would, again, so you have complex, so you go ahead and do that little flipperoo right there, right? And you're basically doing 2 over radical 2, 2 over radical 2. This all goes away. You're either using your calculator, or you're using your brain, you're using something to multiply this out, and you end up with 1. 1. Okay. We'll try 150. So here's 150. Here's your x. Here's your y. Or in our case, remember, we're actually considering it sine and cosine. Okay, remember, keep that in mind. And so we're going to do 1/2 over negative radical 3 over 2. And remember, no complex fractions. This ends up canceling out. I don't know. Figure out how you're going to get this answer. Mathematically, well, these 2's cancel out, so you're left with 1 over negative radical 3. Okay, and then the last one at 180. Well, that's an easy one. That's just 0 and 1, right? I don't even need anything crazy over here. So that's 0 over, I think it's a -1, yeah. And then that ends up being just 0. So there you go. That's finding or identifying the tangent function on the unit circle. So again, so since we're dealing with fractions here, right, in the tangent function, there's a chance that you can be undefined. Remember, to be undefined means that the denominator is going to be 0. So you have to be careful to make sure that when you're doing it, that the tangent function it would be undefined, therefore you couldn't do that one. And here you go. Consider the angle theta at 90 degrees, or pi over 2 radians. And that's right here. 0, 1. 0, 1. State the values of the sine and cosine at this angle. So the sine of 90, and remember that's your y point, would be 1. The cosine of 90, remember that's your x point, would be 0. So why would the tangent of 90 be undefined? Because remember, we are doing sine over cosine, and we just define that as 1 over 0. And there you go. That makes it undefined. Okay. So now the next one, I'm giving you a whole bunch of angles, and I'm saying, well, which one would give you an undefined fraction? So here it is there, if you want to pause and give it a shot on your own. Okay, which one would give you an undefined fraction? So they give us 0, 270, 120, and negative 180. Now, to be an undefined fraction, remember it's our denominator. So it's basically, when is the cosine function going to be equal to 0? And remember, our cosine function is going to be our x value. So we don't want the cosine to be 0. So here we're looking at 90, 180, 270. And there it is. The cosine is 0. That's the guy that's going to be undefined. So here we go. Let's now try to wrap this all up and see if it all still makes sense. So it's interesting that if we know that the sine or cosine of an angle and the quadrant of the angle, we can find the other two missing trigonometric values. So this is now kind of getting away from only those special areas in the unit circle. So to determine the value of cosine theta and tangent theta, if sine theta is equal to 5 over 13 and the terminal ray of theta lies in the second quadrant. What does that mean? So basically, they're asking you for the cosine, which we're calling x, right? The tangent, which I would need sine over cosine, so I would need these two answers to actually figure out the answer. And the terminal ray lies in the second quadrant. Well, remember, the terminal ray is where the angle was. So this is the second quadrant, and that's basically where I am. So if I'm going to now look at this as a right triangle, it would look something like this. Now they're telling me that sine theta is equal to 5 over 13. Think about what we were just learning before. Okay, and I'm saying way before baby geometry stuff, right? And that is a squared plus b squared equals c squared. Now, if you're thinking that in terms of the unit circle, that's basically kind of looking at like x and y. So x squared plus y squared equals c squared, or in the unit circle would be the radius. So you can kind of look at that like this, right? This is your x, this is your y, and that's the radius because this is a circle, which in a unit circle is a 1. So it's like having sine squared theta plus cosine squared theta equals 1 squared. Okay, it's kind of using the Pythagorean Theorem again. Now they already told me that sine theta was 5 over 13, so it's 5 over 13 squared plus cosine squared theta equals 1. I can now move this to the other side, so it's cosine squared theta equals 1 minus 25 over 169. Right? I did 5 squared and 13 squared. That's where I got that from. Now I could just, again, use your calculator. What's 1 minus 25 over 169? And I'm going to write it up here. So cosine squared theta equals, I have 144 over 169. Now we have to square root this to figure out what cosine theta is. And that's going to be 12 over 13. All right, so there it is. Now I have the cosine by using the Pythagorean Theorem. Now we learned before that tangent theta is sine theta over cosine theta. Sine is 5 over 13. Cosine is 12 over 13. Now, get rid of this guy. And we're going to end up with 5 over 12. All right, so there's the basics. Now let's be careful now because it can't be that easy, right? Remember, when you take the square root, this can either be a positive or a negative number because 5 squared is the same as having negative 5 squared, right? So they're both 25, but it could be either a positive 5 or a negative 5. And that's where this part comes in handy, or that's important. This would be a negative value, and this would be a positive value. So it's your job now to understand that this x, which in this place, is going to be a negative number. So that actually is going to be a negative 12 over 13. So then I just have to kind of throw a negative here, and then it ends up with a negative 5 over 12. Before you go ahead and do all this work here, figure out if he's positive or negative. I just wanted to make sure everybody kind of stayed with me before I did that. So we'll make sure that we kind of follow the order when we do this last one here. Now you're going to look at this one or try to read this one and say it's impossible, but it's exactly the same as number 6, except there are no numbers involved. So you have cosine theta, which is a. So over here was a number, now it's just a variable. A is greater than 0. And the terminal ray of theta lies in the 4th quadrant. So if you're drawing that, you're here. So then keep in mind that this number would be positive and this would be negative. So your cosine is positive and your sine is going to be negative. Right? And that makes sense because they told us that there. Then what is the value of tangent theta? I'll do it down here. So tangent theta is sine theta over cosine theta. Now they already told me cosine theta because cosine theta is a. Now I have to figure out sine theta. So let's use the Pythagorean Theorem. Sine squared theta plus cosine squared theta equals 1 squared. That's sine squared theta plus a squared equals 1. Sine squared theta equals 1 minus a squared, because we moved him to the other side, and square root that. So sine theta is 1 minus a squared, right? Now, is it positive or negative? Well, we just kind of said before, and he is going to be a negative. So here I'm going to plug in negative square root 1 minus a squared. And there it is. All right, so that's it. Hopes that helps. Leave a comment, subscribe, whatever it is I can do to help you even more.